Okay, so you get a couple solutions here. Let's, oh, what happened? Negative x equals 5, positive 5, so there should be a negative in there. Just testing you, that's all. Okay, so negative 5 and positive 1. And now we need to double check them quickly. So if I plug this in, negative 5 minus 4, that equals to 9. So if I plug it in this time, I get 2 times negative 5 plus 1 is negative 9. So this solution doesn't actually work because the 1 time tells me it's positive 9, but when I substitute it in, I get negative 9. So this is one of those instances where it didn't work out. Over here, when I have 3x x equals to 1, this would be 1 minus 4. So I end up with 3, and I'm going to compare that with 2 times 1 plus 1, which is 3. So yes, this one does work. Okay, so x equals 1 is the only solution for this answer. Okay. So let's possibly try, let's try one more. We won't do both today, but let's try one more. See what you come up with for this x plus 4 equals 3x minus 8. Okay, so for this example, we only end up with the one answer, which is x equal to 6. X equals 1 needs to be rejected. We end up with negative 5 if we do that, not the positive 5 we were hoping for. Okay. Okay, so we're going to take a look one step further with these absolute value equations, what we can do. And this is when we've got two absolute values in here. So if we have two absolute values in our equation, now it kind of gets confusing, like, well, who becomes positive, who becomes negative, and how do I juggle all that around? Well, the good news is we can proceed like we normally did, which is to make one positive and one negative, and then if you end up checking all 4 cases, you'll still find out that you only need 2. So what I mean is, it's still enough to try solving just 2 equations like this. Okay, that's still enough to solve it, even though there's 2 absolute values there now. You don't need to do all 4 when this one's positive and that one's negative and that one's negative and this one's positive. Okay, your brain will probably explode halfway through that. So we'll give this one a try. Again, you still have to double check your answers. So when you finish it, don't forget to double check. Oops, no, have I done that? Let's just see here, 3x. Oh, I don't like fractions. I was just hoping I didn't have to deal with fractions. Okay, so 4/3 and 1/3 is 7/3. And then I have to compare that with 2/3 minus 3. thirds minus 9 thirds, which is 7 thirds. Okay. So in this example, it turns out that we have two solutions. Okay, and again, if you think about your the pictures, if you have one absolute value here, and you want to know how many solutions you could get, it's possible that the other absolute value crosses twice, crosses once, or maybe they don't cross. Yeah, maybe they don't cross at all. That's possible as well. Okay, so we still need to check to make sure that they do cross.
Is it possible that they don't cross?
Yeah, it is, because if I have one absolute value graph like this, and then I put the same graph directly above it.
Can it be above it?
Yeah. So this, for example, if I went absolute value x, and then I went absolute value x plus 1, then those would never touch, because it would be, every point here is exactly 1 higher. It's not fair. They'll never meet because that one's always 1 above it. Make sense? So anyways, it is possible that there is no solution, just like a parabola. Okay? So we'll skip the next one because it is a very similar idea. Da-da-da-da. Okay. So I'm going to pause for a second here.